Okay guys, here's our last video on moles, and we're going to use this flowchart to be able to do two-step problems. Okay, so if I were to give you mass, I would use the molar mass to convert to moles. If I was given moles, I would use molar mass to convert it to mass. The same thing with particles. If I was given moles, I would use Avogadro's number to convert it to particles. If I was given particles, I would use Avogadro's number to convert it to moles. And then I can do two-step problems as well. So if they give me mass, I use molar mass to get to moles. But if I want particles, I just go ahead and use Avogadro's number. So in the example, I have 23.5 grams of lithium. I need to know how many atoms of lithium I have. So if they give me mass, I'm going to use the molar mass from the periodic table. Lithium is 6.941 grams in 1 mole. So those cancel out. I'm left with moles. So I'm going to use Avogadro's number to find the atoms. My mole has to go here because I need it to cancel out. And here, 6.02 times 10 to the 23rd atoms of lithium. And when I do my math, remember, you're going to multiply across the top, so 23.5 times 6.02 times 10 to the 23rd, and then I'm going to divide by 6.941. So the answer is, and I have 3 sig figs, right? So 2.04 times 10 to the 24th atoms of lithium. So we're going to talk about one more thing here, and that is chemical formulas. So chemical formulas are going to tell you what atoms are in your compound and how many of each atom there are. So for example, if I look at this formula for Freon, Freon has 1 carbon atom, 2 chlorine atoms, and 2 fluorine atoms. So why is that useful to me? So you can write these numbers as a ratio. So I can say the ratio of carbon to chlorine to fluorine atoms is 1 to 2 to 1 to 2. In 1 mole of Freon, I can write all of the mole ratios. I can say in 1 mole of Freon, I have 1 mole of carbon. In 1 mole of Freon, I have 2 moles of chlorine. And I can say in 1 mole of Freon, I have 2 moles of fluorine. Okay. Why would that be useful? So let me show you a problem that you might see. So how many moles of fluorine atoms are in 5.5 moles of Freon? So remember, your diagonals have to match. So here, in 1 mole of Freon, I have 2 moles of fluorine. So that's 11. Okay, so that's the kind of thing you might see. Let's do your other problem together. How many moles of carbon are in 3.50 moles of the stuff? So carbon, I have 6. So in 1 mole of this stuff, I have 6 moles of carbon. You have 21, and we need 3 sig figs, so 21.0 moles of carbon. But what if we needed the molar mass of a compound? Okay, so molar mass is also known as atomic mass, and it can be found by looking up on the periodic table. So let me show you how to do this for a compound. So for a compound, I'm going to take the molar mass of carbon. Carbon is 12.01. And I need to multiply by 2 because there's 2 carbon atoms in that compound. For hydrogen, it's 1.01, and I need to multiply by 3 because there's 3 in that compound. And for oxygen, the mass is 16, and I need to multiply by 2. So I'm going to do that, and then I'm going to add them all up. So the mass of acetate is 59.05 grams per mole. So once you get that, then you can use it in the problem just like we've been doing. So what is the mass of 2.5 moles of water? Well, in 1 mole of water, I need to figure out the mass. So H is 1.01 times 2, and O is 16. So 18.02 grams per mole is the mass of water. So then I'm just going to multiply. 45 point, and I'm just going to leave it at 45 because there's 2 sig figs. 45 grams of water. From this point, you guys are going to do a bunch of practice understanding these concepts, also practicing these problems, and I'll be with you to help every step of the way.